A vertically loaded hydraulic cylinder will require a lock valve of some sort to hold the cylinder at a mid-stroke position, or perhaps a counterbalance valve to prevent runaways while lowering a heavy load. A directional control valve is seldom relied upon for these functions. In this video, we will install a pilot-operated check valve into the lower hydraulic cylinder line. A check valve typically provides a positive fluid lock with no perceptible internal leakage. The orientation of the check valve in this circuit, as shown by the symbol, normally prevents flow from right to left while allowing flow from left to right. But a special third connection, called a pilot port, when pressurized, will in fact allow right to left flow. There is no flow on this dashed pilot line. It is only a pressure signal to a piston inside the check valve that lifts the ball off the seat during that right to left flow. Let's operate the directional valve to retract the cylinder, raising the load. Releasing the handle on the directional valve shows us that the pilot-operated check valve is indeed holding the load. Notice the graph that shows the cylinder position over time. Now let's operate the directional valve to lower the load. The check valve opened and slammed shut several times during the lowering of the load, creating a very uneven cylinder motion. The time period between open and shut events will be longer for large hydraulic systems or lighter loads, and shorter for heavier loads or for smaller systems. As the load and the cylinder rod ran away with the help of gravity faster than the rate of fluid supplied by the pump and directional valve, the pressure in the upper cylinder line dropped to a very low level. In some circuits, the pressure may even drop into partial vacuum. When this occurred, there was insufficient pilot pressure to keep the check valve ball off the seat. With a spring and pressure on the right-hand port, the check valve naturally slammed closed. Let's retract the cylinder and extend it again and observe the pressure in the upper cylinder line while the load falls. Whenever the check valve halts cylinder motion, pressure builds in the upper line once again, piloting the check valve to the open position. Cylinder motion resumes and accelerates, and the runaway motion control problem repeats itself. To solve the uneven motion problem, a needle valve has been installed in the lower cylinder line. Let's adjust the needle valve to create restriction and see what happens as the cylinder extends this time. The needle valve imposed back pressure on oil leaving the lower cylinder line, which in turn created pressure in the upper cylinder line. With the upper cylinder line held constant, pilot pressure at the check valve is also constant, keeping the check valve ball off the seat, allowing for even flow. The problem with uneven motion has been solved, but at the expense of cylinder speed. The disadvantage of this particular solution is that the use of the needle valve makes the cylinder speed very slow. In the next video, we will install a counterbalance valve and see what effect it has on cylinder motion while lowering a heavy load.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up.